So, welcome to our lesson 3, chapter 1, still in chapter 1. So, lesson 3 talks about null sets or and equal sets, not or but equal set and equal sets. So, we have here our first problem is to list down the elements of set A. And as a review for lesson 2, set A is expressed in using set builder notation. So A is the set of all multiples of 9 between 10 and 15. So simply what we do will notice in this set is that there is no multiple of 9 between 10 and 15. So how can we list down that? Okay, how can we list down that? So we have, that is actually our lesson for this part. So let us consider counting numbers that are divisible by 7 and 22. So the numbers between 22 and 27 are 23, 24, 25, and 26. So as you can see, between 23, 24, 25, and 26, there is no whole number there that is divisible by 7. So if you're going to list down the elements of set M, okay, there will be no element to list because there is no member in that set M, because you cannot really find any number between 22 and 27 that is divisible by 7, any whole number. Okay, so set M is an example of empty set, or we call it null set. Okay, call it null set, empty set or null set. So what are empty sets or null set? Empty set or null sets are those with no elements. Okay, we can write set M above, so we can write it in two ways. M equals empty braces, or M just equals to this one. Note that we cannot write it like this. So work example 1, we have, let's try to determine if each set is either an empty set or not. So even numbers between 10 and 15. So do we have even numbers between 10 and 15? Yes, we have 12 and 14. So this is not an empty set. Not an empty set. That number 2, days of the week beginning with letter P. This is an empty set because there are no days in a week beginning with letter P. So empty. Number 3, we have a 2-digit number divisible by a 3-digit number. What this tells us is that can we find any 2-digit number such that when we divide it by a 3-digit number, the result is still a whole number. Okay, the word divisible talks about when you divide something by something, the result is a whole number. So a number is divisible by another number. When you divide that number by that another number, the result is still a whole number. So that's what you call divisibility. Okay, so here, can we find a 2-digit number such that when we divide it by a 3-digit number, the result is still a whole number, divisible by a 3-digit number? So no, because when we divide a 2-digit number by a 3-digit number, most likely the quotient will be less than 1. So that gives us 0 point something, which is not a whole number. That gives us this as an empty set. Okay, so let us consider another set below. A equals even numbers between 1 and 10. Okay, then B is X is the set, B is the set of all X such that X is a 1-digit number divisible by 2 less than 10. It's somewhat lacking here. Okay, so if we list down the elements of A, even numbers between 1 and 10, we got 2, 4, 6, 8. If we list down the elements of B, we have still, because it's any 1-digit number divisible by 2, we have 2, 4, 6, 8. Okay, notice that A has exactly the same elements with B. Okay, this gives us that A and B are examples of equal sets. So they are equal sets. We write A equals B set. So equal sets are 2 or more sets with exactly the same elements. Okay, so work example 2 we have here. Let's try to determine if this one is an these are equal sets. So multiples of 2 greater than 10 for A, even numbers greater than 10 for B, Okay, so if we list down A, we have 12, 14, 16, 18. The ellipsis tells us that this set continues until infinity. So that gives us 12, 14, 16, 18, 20, 22, 24, 26, so on and so on. Set B, even numbers greater than 10, so that still gives us 12, 14, 16, and 18. So still, that is until infinity. So as you can see, they have the same, they have exactly the same elements. So A is equal to B. They are equal sets. Number 2, we have here multiples of 5 greater than 10 but less than or equal to 30. So in set N, we have numbers divisible by 10 that are greater than 10 but less than 30. So we have here 15, 20, 25 for M. Okay, this should be but less than or equal like that, or equal to 30. So the elements for M are 15, 20, 25, 30 because that's multiples of 5. And N, those numbers divisible by 10, greater than 10 but less than 30, less than or equal to 30. So that's only 20 and 30. So obviously they are not equal sets. So M is not equal to N.